Guys, in this video I am going to say about ethers. Ethers are of two types: aliphatic ethers, aromatic ethers. Aliphatic ethers are in the form of ROR. Here R and R are alkyl groups. Maybe you can write it as R and R dash, and here Ar represents that it is an aromatic compound. So preparation of ethers. Basically ethers can be prepared by four methods. First one is Williamson synthesis reaction, which can be written as WSR. Next one, modified Williamson synthesis. This is written as MWSR. And next, from alcohols and from diazomethane. Coming to preparations, first one is Williamson synthesis reaction, WSR. So in this, first we will take an alkoxide. Upon reaction with alkyl halide gives you ether, and this reaction follows the SN2 mechanism. And here mainly the alkyl halide which is taken must be primary alkyl halide, 1 degree Rx. So that is RF, RCl, RBr, Ri. These are primary alkyl halides, and this structure is RO minus. It is alkoxide ion plus Rx gives you the ROR plus X minus. So this is the reaction actually. The mechanism involved in this is, see here, mechanism. Coming to mechanism, Rx. So X will be removed and X minus plus R plus RO minus. So this RO minus R plus will form ROR, and rest is the byproduct X minus. So in such way Williamson synthesis reaction takes place. Okay, let us take some examples regarding this. So first one, CH3O minus RO minus plus RX. Next one, C2H5Cl. So ROR, that gives CH3O C2H5, and Cl minus is the byproduct. So next one, so second example is CH3O minus plus C3H7Cl. It is primary alkyl halide that gives you CH3O C3H7 plus Cl minus. So in such a way it follows. Second preparation is internal Williamson synthesis reaction. Here the substrate used is halohydrin. So let us take some examples. Initially we had taken this, and in the presence of OH minus and H2O. So the final product formed is a cyclic compound. It is not aromatic, but this is an ether. As it is in the form of ROR. And it is a cyclic compound. So second example, let us take with a benzene ring. Actually this is the benzene ring, Br, pi bonds, and this is in the presence of, as it is, OH minus and H2O. So we can get ether. So ether will be obtained in the second ring. So here what happened is that some rearrangement takes place. Due to rearrangement, due to the rearrangement, this bond gets closed up, and here either will be formed at this point. So at here a bond will be formed, and then at this point oxygen will attack. So here OH minus now, so this OH minus attack here to form the ether. Okay, third preparation is that from alcohols. Alcohols are of form ROH, and it's primarily depends upon the temperature. So I will explain you in detail. Let us take ethyl alcohol CH3 CH2OH. This is ethyl alcohol, and here we will be using the reagent concentrated H2SO4. Concentrated H2SO4, and at temperature 140 degrees centigrade. So this will be forming an ether, that is CH3 CH2, CH3 CH2O, O, CH2 CH3. So why is the here 4 carbons are formed? Here 4 carbons formed, but here we had given only 2 carbons. This is because we will be taking 2 moles. So this is the first example, and at 140 degrees centigrade. But in other cases we will be taking an extra amount of temperature. So let us have a look at that. CH3 CH2 OH, same ethyl alcohol. Now Al2O3, reagent taken is Al2O3 at 250 degrees centigrade. At 250 degrees centigrade, so 2 moles. 2 moles of ethyl alcohol will react with Al2O3 at the temperature of 250 degrees centigrade to form an ether. That's it. Okay. The fourth preparation is from diazomethane. So many members have a doubt, what is diazomethane? Diazo. Azo in the sense nitrogen. N2 methane CH, actually CH3, but one bond will be occupied by the N2, so that's the reason why CH2. CH2 N2. 2 bonds will be occupied by nitrogen, and remaining 2 will be occupied by hydrogen along all the 4 sides of carbon. So CH2N2 is the molecular formula of diazomethane. Actually here also we will be taking alcohol ROH plus CH2N2. So alcohols react with diazomethane to form either ROCH3, and the byproduct formed is N2. So mechanism, did you understand? So here OH minus, it is OH minus. From this OH minus, so CH2 will attack here, so and that will leads to formation of ROCH3. And mainly next one, so if what happens if we take a phenyl ring, phenyl in the sense benzene ring. So this is the benzene. I will be taking the phenol, okay, phenol plus CH2N2. Definitely compulsory we must contain OH minus. So because we need oxygen atom to form ethers, so that's the reason why I am taking phenol. So it is the phenol. C6H5OH is the molecular formula. So PHOCH3, OCH3 plus N2. Here it is the ether, because let us take this whole pH as R, O, this CH3 as R dash, some other alkyl group. So RO R dash is the structure of ether. This is the last preparation, but not least. It is the very important preparation. And so here we will be taking alkene. It is alkene, and next example also alkene. So here the reagent plays the major role. Reagent plays the major role because reagent is very important here. So here this double bond will be removed, so that here plus charge will be acquired. Due to the plus charge, O minus will attack here and that leads to the final product, and that's the mechanism. So coming to this one, here also double bond will be removed so that here plus charge will be formed, and here propene, this is the propyl alcohol. From this propyl alcohol OH minus will be removed. Whenever OH minus is removed, so here propyl will be attained with positive charge. So here by attacking of propyl at here, by attacking of OH minus at this compound, because it is plus and it is minus, so that ether will be formed. So this is the oxygen ether. So in the above example also ether. So these are the different preparations of ethers. These are industrial process to prepare ethers. So whenever we need to prepare ethers, we can prepare by these any of the methods. Thank you.